is a UH-101 hydraulic chaining system. Firstly, let's see the power unit. At your left side, when opening the door, we find the hydraulic power unit. It's a hydraulic pressure pump, and just near it is a pressure gauge. There is a knob for adjusting the value of pressure. Outside, there are 3 buttons. The green one is for start the system and the red one for stop. We also have an emergency button for stopping the system immediately. Then in our working bench, there is an oil catcher at the left side. There are 4 oil outputs with the oil pressure gauge to show system pressure. At the right side, 4 oil inputs is for the backflow of oil. And at last is a diaphragm accumulator. It's one equipment required on our experiments. Below there are 4 drawers. It's for the storage of hydraulic components. As for our working plate, it's a grooved one. Easy to put components on. All our components are designed for it. They all have a quick plug-in connectors. When using, just push the 2 sides of components slightly and mount it on. It's well fixed. For taking it off, push again like this way. Then you see the PLC control panel. It's possible for students to practice electrohydraulic exercise. In fact, our trolley is 2-sided. Now we are going to see the rear of trolley. It's the same design idea. We have push buttons for start and stop the system, drawers for the storage of hydraulic components, and also grooved plate for mounting components on. Then we are going to present an exercise of flow meter out control circuit. The object of this exercise is to move the hydraulic cylinder precisely to its supposed position. The components required are 2-way throttle valve, 4-pole 3-position directional control valve, and double-acting hydraulic cylinder. Now we connect all components together by tubes. Firstly, from oil catcher to P-pole of directional control valve. Is for the input of oil. and the T-pole for the backflow of oil. Those are all quick plug-in connectors, very convenient for building a circuit in a short time. Then A port, output of oil to the hydraulic cylinder. After we connect the directional control valve to cylinder. Now the system is done. Let's see how the system functions. Firstly, turn the power on and adjust the value of pressure to 40 kg, or as the need of user to adjust it. Now we set to 40 kg. When we push the stick up, the pressure goes from P to A pole, and for backflow is from B pole to T pole. So when oil pressure passes from P to A pole, the cylinder will move down. In the middle position, those four poles are not connected to each other. If we push down, the cylinder will move up, because oil pressure goes from P to B pole, and for backflow is from A to T pole. Let's see how it functions. Now we are going to show you what is flow meter out control. It's when the cylinder moves up or down. We can control the flow rate here. Suppose a heavy object hangs below. We want the movement to be slowly. We can adjust the knot here. If there is no throttle valve, the movement will be faster. But with a throttle valve, we just need to adjust the flow rate here in order to make the movement slowly. Since it's a two-way throttle valve, so the user can control the speed of movement when it's to up and also to down. If we close the valve, the cylinder stops to move. Again, we can adjust the flow rate here. The advantage of flow meter out control circuit is having more pushing forces, so it can move the cylinder slowly to the supposed position. Even with a heavy object, it can function with a stable speed. Because all movements are controlled by throttle valve. For stopping an exercise, we need firstly turn the power off. Then release the pressure in the circuit. Only when the pressure in circuit is zero, we can start to take quick plug-in connectors off. Then we are going to do an experiment of pressure reducing circuit. Components required are double-acting hydraulic cylinder, pressure reducing valve, 4-pole 3-position directional control valve, and a line check valve. Now we connect the components to each other. The pressure reducing circuit is completed. Firstly, we turn the power on. When we push the stick up, two cylinders move forward. But while those two cylinders actions with two different speeds, because the lower one, the cylinder B, passes through a pressure-reducing valve, and the first one, the cylinder A, not. So in this exercise, students can observe the difference between cylinder A and B and why the cylinder B moves slower than the cylinder A. In fact, you can see when the cylinder A arrives to its initial position, all pressure turns to cylinder B. That's why the cylinder B runs faster than its usual speed. The same when moving forward. When the cylinder A arrives at extreme point, the cylinder B will go forward faster. We can adjust the pressure of cylinder B here. This is our experiment of pressure reducing circuit.